Okay, so welcome to the second video for our algebra classes here. We're going to be talking about exponents again, but we're going to carry it over now with coefficients. Okay, so what that means is basically that we're going to have our x squared and our exponent, but we're also going to have numbers in front of them. Those numbers could be positive or negative or even fractions in some cases. Although today we're not going to worry about fractions. That's something that the same principles and rules will apply, but that'll be something you can worry about later. Okay, so starting off, we're going to look at multiplying exponents with coefficients. Remember, the rule for multiplying exponents is we add the exponents. We're going to assume you know those rules from the previous video and just apply it to what is different now that there are numbers in front. So basically the rule is we're going to take it separate. We're going to look at the multiplying the numbers first, I should say part separately, and then we're going to multiply the variables second. So looking at this example here, what I'm going to do is I'm literally going to go ahead and I'm going to write off to the side each part. As you get better at it, you don't really need to do that, but at the beginning it's a good, helpful hint to get you started. So I'm going to go ahead and write 7 times 3. And those are my two numbers that go along with the problem. And then I'm going to treat the second part separately. S to the fourth times S to the fifth. And I know I wrote them out of order, but it doesn't matter in multiplication. So now I can do is each part separately. 3 times 7 is 21. And S to the fourth times S to the fifth is S to the ninth. And that's it. Now all I have to do is put them together. So remember my answer was 21 and then S to the ninth. We're going to do the same thing on the second example here, which is negative 4r to the second power times 7r to the fourth power. I'm going to go ahead and I'm going to treat each piece separately. Negative 4 times 7. And then r to the second times r to the fourth. This right here gives me negative 28. And then r to the second and r to the fourth, adding exponents, I get r to the sixth. I'm circling my answers here just as a force of habit. We want to start developing that process so when you have a bunch of work on the paper, it's easy for your teacher to find it. So I'm going to go ahead and have you try a few now. We're basically going to do this a little bit different in that I'm going to give you one problem at a time. So each time I give you a problem, you're just going to go ahead and pause the video. And I'll put the little screen up at the first time, but pause the video, try that one, check your answer. And this is just because I don't want you to do a bunch of them wrong and then get frustrated if you're making mistakes. So go ahead and pause the video, give it a try, and then hit play when you're ready. Okay, so the first thing, 4 times 9 is 36. And when we multiply our exponents, we add them together. 4 plus 9 is 13. Okay, so hopefully that you got that one right. If not, figure out what your mistake was and apply it to the second one. So here's your second example. Go ahead and pause it, try it. A couple seconds later, I'll go ahead and answer the question. All right, so hopefully you tried it. Negative 2 times 12 is negative 24. Remember your integer rules. And c to the 8th and c to the 9th makes c to the 17th. Third example. Go ahead and pause it, give this one a try. All right, so if we multiply those numbers, we're going to get positive 20 and x to the 14th. That's from adding 6 plus 8. You'll notice on your paper you have 4. That's going to be the case for all of them. The last one is just sort of a challenge. So if you're really getting these right and you feel confident, go ahead and give this one a try. Pause the video and go from there. It's not super hard, just one level up from what you've done before. Okay, so the first thing you have to be careful about here is you have 3 numbers. Negative times negative for the 2 and the 3 are going to make a positive 6. Okay, and then 6 times 4 is 24. You don't have to go in that method, but it works best to me. Now I'm going to go ahead and add up my variables. 7 plus 5 plus 2 is 14. And that's it. Next thing we're going to do is we're going to do simplifying. Now basically the reason I call it simplifying is very much like a fraction when you're dividing out of the top and bottom. It also is basically dividing, but I'm looking at it as simplifying simply because that looks a lot like a fraction when you simplify those. So here's our first example. What I like to do is I like to use a method called which has more, top or bottom. You can also straight up just use the division rules. However, that's going to leave you with some negative exponents sometimes. So we can look at both ways, but what I like to do and what's worked for my students over the years is to say which has more for each variable, top or bottom, and then how many more does it have. So we're going to start off with the x's. If I take a look here, I've got 2 on top and 4 on the bottom. So which has more? Obviously the bottom has more, which means the x's are going to end up on the bottom of my problem. How many more does it have? Well, 4 has 2 more than on top. So it's x to the second. Looking at the y's, I've got 2 on top, and then you have to think how many are on the bottom. It's not 0. When there's no number on an exponent, it's a good idea just to throw a 1 on there. That way you remember that it's still to the first power, because anything to the 0 power is 1, and therefore it wouldn't even be y, it'd be gone. So now I'm going to compare here. There's more y's on top, and there's 1 more. So I have a y to the first on top, which is the same as just y. Okay, the writing it out long way method. I'm going to show you both ways just so you can make sure you understand. That would be to go ahead and take that and write it out the long way. So I'm going to have 2 x's on top and 2 y's, and on the bottom 4 x's and 1 y. And then all I'm going to do is simplify from top and bottom. 1 pair of x's, a second pair of x's simplifies, and 1 pair of y's can be simplified. What's left over? A y on top and 2 x's on the bottom. So you can see we end up with the same answer either way. There's not a better way or a worse way to do it. I would definitely get away from the subtraction only, just because you're going to have negatives and you have to deal with those. And I would probably focus on one of these 2 methods. But you know, even if you want to take that route with it, I support you on that, and I will go ahead and help you individually. So we're going to go ahead now. We're going to try a few out, starting just like last time. Each time you're going to pause it, try it out. At the end, go ahead and hit play, and we'll see if your answer is right. All right, so first things first, we're going to go ahead and make our fraction bar. This reminds us that there's a top and bottom. I'm going to look at my x's. There are more x's on top, 5 is more than 3, and there are 2 extra. Looking at my w's, again, the larger number is on top, 7 compared to 4, and that means there are 3 extras. It's totally fine that everything ends up on top. However, you don't just have a bottom that's empty, so you should put a 1 there. Your final answer could just not even have the 1, but as a practice right now, we're going to go ahead and leave a 1 if nothing's there. The second example you're going to do, go ahead and pause it, try this one. Okay, so what we're going to do now is we're going to draw our fraction bar. We're going to look at the v's. Here, we have an extra v, 1 extra on top compared to the bottom because 8 is 1 bigger than 7. You're going to have 10 on the bottom and only 3 on top, so there's going to be 7 extra on the bottom. And that's it. Your third example, pay attention here to the fact that you have a 9 and a 9 and think about what that might mean when you're doing the problems. So pause it, hit play when you're ready. Okay, so on the bottom, we have 7 x's, on the top only 2, so that means there are going to be 5 extra on the bottom. Now here we have the same amount of v's on top and bottom. What this means is that basically there are no extras, so there are no leftovers anywhere. Another way to look at it is all 9 are going to cancel if we're crossing them off on top and bottom, and there's none left over. However, we can't just have an empty half of a fraction, so we're going to go ahead and put a 1, which is why it's so important to start the problem out by putting a fraction bar. Okay, the challenge problem down at the bottom here, as you can see, I've got 4 different variables going on. So pause it, give it a try. If you can do this one, you really get this concept. All right, I'm going to start with my a's. I have 3 extra on top compared to the bottom. For my b's, I have extra on top, and there are 9 of them. For the c's, there are 6 extra on the bottom compared to the top, and the d's are completely canceled out. Okay, so now we're going to look at how to simplify exponents with coefficients in front of them, meaning numbers in front of them. Okay, remember again, we're going to follow that same rule of which has more, top or bottom. However, we're also going to go ahead and deal with the numbers separately, just like we did in the last example. So taking a look right away, as you can see, we've got 12x to the 8th, y to the 9th on top, 48x to the 13, y to the 7 on the bottom. So we're going to start off simply looking at the numbers themselves. Okay? If we simplify 12 over 48, we get 1 over 4. If you're unsure of that, I'll give you a quick diagram. I'm going to go ahead and I'm going to divide this by 12, which gives me a 1, and 48 divided by 12 gives me 4. You could also break that down into smaller pieces, divide by 3, then divide by 4, like that, and it would still work. Eventually, when you simplify, you get that. A good idea as well is to take that fraction off to the side, just like I showed you on the other one, and simplify it like that. Okay, now we're going to apply our normal rule. We have 8 on top and 13 on the bottom. Which has more? The bottom. How many more does it have? 5 more. So right off the bat, I've got 5 more on the bottom. Now I'm going to look at my y's. I've got 9 on top and 7 on the bottom. Which has more? Top. How many more does it have? 9 is 2 bigger than 7. And that's it. As soon as that's simplified, you're good to go. Now, a quick check is to say, hey, can I simplify any more? Is there still a letter on top and bottom? Is that number simplify more? Nope, it doesn't, so we know we're done. Okay, following that same thing, you can feel free to watch this again if you need to, but we're going to try some on our own, same way as before, one at a time, and pause it. So go ahead and pause this, simplify the numbers part first, make it a fraction, and then go from there. Okay, so if I simplify 12 over 15, that divides in by 2 each time. So I'm going to end up with, not 2, by 3. So I'm going to end up with 4 on top and 5 on the bottom. There are 8 x's on the bottom and 5 on top, so there are more on the bottom and there are 3 more. And there are 5 extra w's on top. Moving along to the second example, go ahead and pause it. Try it again. Okay, 30 over 60 simplifies out to 1 over 2. There are 5 x's on the bottom and only 2 on top, so that means 3 more on the bottom. And there are 8 on the bottom for r's and only 6 on top, so there are 2 extra. I put that 1 in the center on top. You could have put it on the side. You don't have to worry about it being perfectly centered. Go ahead now and pause it again. Try the third example. All right, so we're simplifying 24 over 18, which simplifies out to 4 over 3, because 6 divides into each of those. So remember, write it separately, simplify it that way if you need to. There are 8 on the bottom and only 2 on top for my x's, which makes 6 on the bottom. And there are 9 on top for v's and only 1 on the bottom, which make 8 extra on top. Okay, remember the last example is sort of a challenge to you, so you can see a lot of variables going on there and a little bit bigger numbers. So go ahead and pause it and give those a try. All right, so we're going to go ahead and simplify. 30 over 6 is, simplify out to 5 over 1, so a 5. We look at y's, we've got 3 extra on the bottom and only 2 on, so 5 compared to 2. X's, there's the same on top and bottom, so they completely cancel out. And z's, there is 1 extra on the bottom compared to on top. So again, comes out to be a nice simple answer, but starts out kind of complicated. All right. The last main concept we're going to talk about is exponents raised to more exponents. So we've already done this without a coefficient. This is one that we want to be really careful about. So when we raise an exponent to a power, we do 2 parts. First the number, then the exponent. Same as everything else. I really want you to be careful though, however, on this one. My example here is going to show the short way, but before that I want to go ahead and show you the long way. And I highly recommend you follow the long way just on this one method, which is this right here signifies that you need to write it 2 times. So I want you to go ahead and write it out times itself that many times. Okay, what you probably notice now is this is a problem just like the one we practiced at the beginning. Now we multiply 7 times 7 and apply our exponent rules. That will give you 49w to the 6th. Okay, another way to do it, the shorter cut, is to say, okay, I'm going to put a 1 on that 7, and I'm going to multiply both of those numbers outside. So I'm going to get 7 to the 1 times 2 is 2, and 3 times 2 is 6. The reason I don't like this is because very often the answer I'm going to get from students is going to be 14w to the 6th. And that's because they're taking a 2 and multiplying it by that 7. Not 7 times 7, but 7 times 2. Because of that, I really recommend that you write it out completely. Okay, a second example, just so you could see another one, is this right here. Again, a lot of people are going to put an 8 there. They're going to do 7 times 4, but they're going to put an 8. It's not 8. It's 2 to the 4th. Okay, 2 to the 4th is equal to 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So you have to be very, very careful. S to the 7 times 4 is 28, and we're done with the problem. If you just would have written it out, it would have looked like this. Okay, and I'm just going ahead and write those 4 times. And then I would have gone 2 times 2 times 2, and I wouldn't forget. Just to remind me there's that many 2's involved. Okay, so pause it and try the first one. All right, hopefully you tried it out. Be very careful here not to get 10w to the second. It's actually 25, because 5 times 5, and 4 times 2 is 8. Trying the second one, pause it, give it a try on number 2, or on B on your paper. 3 times 3 times 3 is 9, times 3 is 27, and then 7 times 3 is 21. Your last example, before the difficult one, go ahead and pause it and give it a try. Again, be very careful not to put 10 here. 2 to the 5th power is actually 32 if you actually multiply it all the way out. And then 6 times 5 is 30. The tricky one I wanted you to try, not too tricky, just that the numbers are going to be a little bit larger, and I want you to remember that and be careful about that. So go ahead and pause it and give it a try. All right, 10 to the 4th is 10 times 10, which is 100, times 10, which is 1,000, times 10 more. So it actually ends up being 10,000, big number, and then s to the 5 times 4, which is 20. So hopefully you're able to get all those difficult ones. Now for extra practice, what I wanted to do is leave a little space so when you get back to class, if you find ones that are tricky for you, you can write them right in there. Or if you want to go ahead and make up a few problems of your own and just see if you can figure them out, you can do that as well. Otherwise, make sure you take the little form down below, fill it out, make sure you answer all the questions, and I will see you tomorrow.